Okay, we are moving into section 4.1, and we're finally getting to chapter 4 about some trigonometry. Section 4.1, we first want to talk about angles and radian measure. So again, please look at the learning objectives, take a glance at the examples we're going to be going over, and let's talk about some things first. So angles. First of all, angles are always measured from the positive x-axis. So the positive x-axis is where we start measuring an angle. If we measure in the counterclockwise direction, that's considered a positive angle. If you were to measure an angle in the clockwise direction, that would be called a negative angle. Okay, so if you go up from here to the y-axis, the positive x-axis to the positive y-axis, that's 90 degrees. All right, or all the way over here is 180 degrees. Keep going, 270 degrees. Keep going, 360 degrees. Or you're back to where you began. And then you could keep going, right? You could say another 90 degrees would be 450 degrees, etc., etc. If I started here and I went backwards, I would say that this is minus 90 degrees, minus 180 degrees, etc. Now, radian measure is measured in units of pi, okay? So it just means, so first of all, 180 degrees is equal to pi radians. So that's actually a conversion. 180 degrees equals pi radians. So in other words, the angle 180 degrees, which starts at the positive x-axis and goes over to the negative x-axis, is 180 degrees, but that is also called pi radians. Okay, so we'll talk much more about that later. But so if I go halfway to 90 degrees, that's 1/2 pi, or pi over 2 radians. Pi radians. Go another half of pi, that's 3 pi over 2 radians. And then go another half of pi, I'm all the way around to 2 pi. So 360 degrees, the same as 2 pi, which makes sense because 180 degrees was pi. All right, we talked about positive and negative angles. So example 1, let's find a positive angle less than 2 pi that is coterminal. Now coterminal simply means has the same ending ray, right? So we always start at the positive x-axis. So 27 pi over 4, that's 27 pi over 4, right? What is that? If I divide 4 into 27, that is 6 with 3 left over, right? So that is 6 and 3/4 pi. So every time I go around, all the way around, I do 2 pi. So if I go all the way around, that's 2 pi. And then I go another 2 pi, that gives me 4 pi. Then I go another 2 pi, that gives me 6 pi, and then I go 3/4 pi. Now remember, half a pi is 90 degrees, a full pi is 180 degrees, so if I go 3/4 pi, that's 3/4 of the way over. So this is my terminal, what's called my terminal ray, my terminal part of my angle. Initial is always the positive x-axis. So again, I just talked down here about 27 pi, the same as 6 3/4 pi. So what angle between 0 and 2 pi would have the same terminal side? So between 0 and 2 pi just means I start at 0 and I go 3/4 of a pi over. I'm at the same terminal ray. So the angle that is between 0 and 2 pi that is coterminal with 27 pi over 4 is 3 pi over 4. Okay, I talked about this already a little bit, but the conversion here is pi radians is the same thing as 180 degrees. So pi radians equals 180 degrees, or pi radians divided by 180 degrees equals 1, or 180 degrees divided by pi radians equals 1. So either whatever form you need is what you do. So if you want to convert from degrees to radians, you want to multiply the degrees by pi radians over 180 degrees, so the degrees cancel. Or if you want to convert from radians to degrees, you want to multiply radians by 180 degrees over pi radians. So the radians cancel. So for example, convert a minus 11 pi over 3 to degree measure. Now they don't tell you that that's radians. Typically the word radians is left off, but as soon as you see a pi there, you know we're talking about radians. So this is a minus 11 pi over 3 radians. So you multiply minus 11 pi over 3 by 180 divided by pi. Notice the pi's cancel. Do some simplification, you get minus 660 degrees. That's just a negative angle measured from the positive x-axis. You go around, You get to minus 360, you go another 300, you get to minus 660. Okay, as a third example, we want to express 16 revolutions per second in radians per second. So a revolution means like the wheel spun around once, right? We have revolutions per second. So one revolution is the same thing as 2 pi radians. So 16 revolutions per second would be 16 times one revolution is 2 pi, so 16 times 2 pi radians per second, or 32 radians per second. 16 revolutions per second, we spin around, we go all the way around once, that's a revolution, that's 2 pi radians. So every revolution is 2 pi. So every time you see the word revolution, multiply it by 2 pi to turn it into radians. 32 pi radians per second. Okay, the length of a circular arc, or often just called arc length, right? The arc length means the length along a circle. Okay, so assume we have a circle here, and the radius of that circle is r, right? Any spoke out, the distance would be r. So the radius of that distance is r. If you want to know the arc length along the circle, right? You want to know the arc length along the circle, that is r times theta. R times theta. So you can kind of see why the arc length, or the circumference of an entire circle, then would be 2 pi r, right? Because the theta would be the entire way around, which is 2 pi. Okay, so the arc length is r times theta. So in our fourth example, in section 4.1, we have a water wheel that has a radius of 15 feet. So this is my horrible picture of a water rail, a water wheel, but this is a water wheel. We've got the water pushing the wheel along. The wheel is rotating at 9 revolutions per minute. Find the speed of the water. So first of all, I want to change revolutions per minute into radians per minute. So again, every time I see the word revolutions, it's substitute 2 pi. So 9 revolutions per minute is 9 times 2 pi, or 18 pi radians per minute. So that means that wheel goes around, so 9 revolutions, it goes around 9 times, which is the same thing as 18 pi, so that's an angle, radians per minute. So then the speed of the water would essentially be how fast it pushes that wheel, which is the same thing as how far does that wheel go when it pushes. That's how much water goes by, or how fast the water is going by. So the speed of the water is the distance the outside of the wheel traveled, and theta equals 18 pi radians per minute. So the distance is your arc length, right? The outside of the wheel, how long it is. The distance the outside of the wheel traveled is r times theta. So the radius was 15 feet. It went around 18 pi as an angle per minute, so 18 pi radians per minute, to get 270 times pi feet per minute. So if you don't like 270 pi, multiply 270 times pi, and you get 848.23 feet per minute. And just for fun, if you don't like that, you want to put it in miles per hour, you would have to take the feet per minute answer, multiply that. Every mile has 5,280 feet in it, and every hour has 60 minutes in it. Put them in the proper order so all the units cancel out to get miles per hour. That comes out to be about 9.64 miles per hour.